Hello everyone, and welcome to this lecture on selection sort. So in this lecture we'll get an explanation of selection sort and look at some visualizations of selection sort. And in the next lecture we'll actually implement it using Python. So the selection sort improves on the bubble sort by making only one exchange for every pass through the list. And in order to do this, a selection sort looks for the largest value as it makes a pass, and after completing the pass, places it in its proper location. So, as with the bubble sort, after that first pass, the largest item is in the correct place. And then after the second pass, the next largest is in the correct place. So this process continues and then only requires n-1 passes for a list or array of n items, since that final item will be placed after that n-1 ist or if pass. So, let's go ahead and see a figure that shows the entire sorting process. So on each pass, the largest remaining item is selected and then placed into its proper location. So in this implementation, we're looking at the largest. In other implementations for selection sort, you can also look at the minimum. So depending on how you actually want to program your algorithm, you could either keep track of the largest elements or the minimum elements, the smallest ones. So in this case, if we decide to track the largest element, we look at our array, notice that 93 is the largest, so we place it at the end. Then, the next largest is 77, so we place it n-1 to the end. Then 55 is the largest, so we place it where it goes. 54 is then the next largest, place it behind 55. 44 is largest, but it actually stays in place. It's already at its correct location right after 54. And this process keeps happening until your list is sorted. So you're basically keeping track of, in this case, your largest element, and then pushing it all the way to the end, and you also have a tracker for where it should go in the array. Okay, and you're able to do this now in n-1 passes. You could have also kept track of the minimum and done this in the reverse. Instead of placing items or elements at the end of the array, you place them at the beginning. So you would start with, in this case, 17 as the minimum and push it all the way to the left. And then get 20 and then push it all the way to the left, etc., etc. So in the visualizations we're going to see, we're going to think about it that way, how you would implement this using a minimum tracker. Okay, so let's go ahead and look at some visualizations. So I've jumped to the Jupyter Notebook under the Sorting and Searching folder. It's called Implementation of Selection Sort. This is a notebook we're actually going to see in the next lecture when we implement this code for a selection sort. Here are some resources for review. And in this case, we can go ahead and check out the visual algo or the selection sort animation. Let's go ahead and do the selection sort animation. So if we get started on that first step, we're going to grab the minimum element, which was 1, and then place it at index 0. And now we're going to go along and look for that next element that's a minimum, and it was 2, so it gets switched with that index 1. Now we're at index 2, and we have element 14. So we're looking for the next smallest number, which in this case will be at index 4, which is 3. And then we're going to do the swap that way. Now we're at index 3 with elements 12, and we're looking for the next item to put in, which will be 4, so we do the swap that way. So notice where 12 ended up here. So now we have at index 4, 14. Next element's going to be 5 here at index 11, and you can do the swap that way. Next, index 6, where's going to be the next item? It's going to be at 7, so you'll notice 10 here. We'll end up here at this index. And you can basically keep running this and do the swaps yourself. And there you go. Now you have an entire sorted array. So this was using the swapping with the minimum. So if you want to see this almost like in slower motion, I encourage you to come and check out visualalgo.net. So almost do that as a homework assignment so you can really get a visual. So let's go ahead and sort this. Actually, it's already sorted, so let's go ahead and create a new one. Random, go. Okay. And then we'll go sort, go, and take a look at what's happening here. So we're going to check if all these numbers here are smaller than the current minimum. So our current minimum is 3. So we started on the left, we're looking for a current minimum. There it is, it's 2. So we're going to push it as the new minimum. Check the other numbers if they're smaller than the current minimum. None of them are not, so swap 2 with 3 here. So notice how that swap took place. So now our current minimum is 38, and it's going to keep getting reset against all the numbers, so we keep going along. And now we're looking for that next minimum, which will actually end up being 3, the number we just swapped. Here now 3 is the current minimum. And you can follow along here with the pseudocode and the status bar, which is actually telling you what's going on. And then the swap occurs. So if we push the speed a little faster, you'll notice the swap's taking place. So it's checking against the minimums and then pushing them to where they belong. All right, so unlike the bubble sort, it's not doing that pair of swapping. You'll notice it's doing way fewer swaps. In that bubble sort, it was doing swaps all along. And here, we're just checking for the new minimums versus the current minimums. In the previous example that I showed you in that presentation, we were actually looking for the largest. So I want you to be aware that you could implement this both ways, either by checking for the minimums or for the largest, and then pushing things either to the left or to the right and doing those swaps, depending on whether you're checking for maximums or minimums. All right, so that list is sorted. Let's go ahead and implement this so we get a better understanding of how selection sort works. Thanks everyone, and I'll see you at the next lecture.